Hey, Math 30-1s. So we're going to go over our last assignment for Trig 2 here. And then get on to the test. And then next week we'll do our perms and cons. Okay, so let's solve these. So we want to prove this identity, and you can see that there's a few different things happening in this one. It's a pretty weird looking one. Okay. Let me just get my cursor in the right spot. That's a good spot for it, right about there. Okay. So I want to get rid of some of these because you notice that I have a difference identity here for sine. I have a sum identity here for tan, and then on the other side I don't have any of that. I just have sines and coses and stuff. So I probably want to get rid of this identity here, this difference identity for sine. So if I look at my identity sheet, I'm just going to put a line. I'm going to put a line for here. I'm going to my left-hand side. I'm going to go down this side. I don't know how long this side's going to be, but I'm going to go to here. I'm going to say sine. Sine differences sine cos. Sine cos, so sine theta or sine pi cos x minus cos pi sine x. Okay, so that's what this piece turns into here, right? So it looks complex, but we know pi is 180. So we know some of this, and this side can be simplified down just a little bit, like sine pi. Pi is 180 degrees, sine is the y value over here. So this is -1, 0. So sine pi is 0. Okay, if sine pi is 0, then 0 times cos is 0. So this whole first term here just disappears. Right? I'm going to write that down. That's going to disappear. And then cos pi is -1. Okay, so I'm going to write that down. So this piece disappears, so 0. And then -1 times negative turns to just sine x. So I just have a sine x kind of all by itself here. Now tan, now this is what's going to happen. It's going to minus. I got tan pi, so I'm going to have to erase this line even more. I'm going to go way over here. Kind of looks like I'm not going to do anything with that side anyway. Tan is a sum identity, is going to end up being tan pi. It's going to be all this stuff here. I'm just going to put a big bracket on that. This is someone, right? Tan pi plus tan x all over 1 minus tan pi. Yeah. -1, right? Yeah, minus tan x. Okay, so I put in what the tan is equal to there, and I'm going to try to simplify this side down. Okay. So it's getting a little bit kind of crazy here. I'm just going to kind of clean this up just a little bit. 0 cos x. This is -1 sine x. So this just turns into sine x. Okay. Actually, I may not want to write it there as well. I might have write it a bit lower down. Okay, so tan pi, tan is going to be, you look at it, think sine over cos, but sine was 0. So the top here just turns to tan x. And the bottom, because tan theta, or tan pi, sorry, is 0. 0 times tan is 0. It's going to be 1. So this simplifies down to a bit nicer number. So I'm going to have minus tan x, and this is going to be, like I said before, sine x. Okay? Now tan is going to be sine over x, like I said. We're going to find a common factor here, or common denominator. So I'm going to multiply the top and bottom of this one by cos x. Okay? So I'm going to get cos x sine x minus sine x all over, because we found a common denominator of cos x. And the last step I'm going to do to kind of match this one, or actually just make it so I can do one thing. I'm just going to multiply this into the brackets because there's no brackets on this side. So I get sine x cos x minus sine x all over cos x. So the left-hand side is equal to the right-hand side there. Whew. That's a trickier one. We'll let you give you enough space for that. Let's try this next one here. We want to prove this identity. So I'm going to put a line right down the middle. I'm not allowed to cross that line. So first I'm going to do, because they have mixes of tans and coses and stuff, I'm going to just change the tan into a sine over cos. And the same thing on the other side here. I'm going to change this to sine over cos. Okay. So sine times sine is sine squared. I got that sine squared over cos x. And this one here is going to end up, it looks like its coses are going to cross off, but if I distribute that square in, like square the top and the bottom, that's going to reduce out, and I'm going to get sine squared over cos x. And that was a little bit easier. That was a nicer one. Okay. So let's try this one now. Better. Okay, so cos 2x, and it has a double angle. The other side has a double angle, but some of these things don't have double angles in them. So it's going to get a little bit tricky. What do? Do I try to introduce new double angles and try to figure out what this tan is? Or do I, well, that's a good one. I could do that. That'd be kind of fun. I don't want to do that though. No, that'd be, okay. I'm just going to get rid of the double angle. So I'm going to turn the sine into 2 sine x cos x. So my goal is to get this. So on this other side, what I'm going to do is I'm going to factor the tan out. You don't have to do this. This is just one way to do it. Factor the tan out, and I'm going to get this. Okay, pretty good. What I'm going to want to do now is, it's going to be tricky. What do I want to do? I want to change, let's change this tan to sine over cos, because the other side doesn't have any tan in it. Okay, and 1 plus tan 2x is technically 2 cos x squared. I'm not going to do it that way. I'm going to replace this here, because you notice that there's no cos x on the bottom here. I want to try to reduce out a cos x somehow. So I want to change this. I want to get rid of the double angle, and I want to leave it as a cos. Right, so something maybe will reduce out with that cos on the bottom. So I want to change that to be 2 cos squared x minus 1. Okay, so the ones are going to cancel out, and I'm going to be left with 2 cos squared x. One of those are going to reduce out. I'm going to have a 2 sine x cos x. And there we go. Left-hand side is equal to right-hand side. Looking pretty good. That's not too bad. Okay, so what we're going to do with these ones, we're going to solve these ones. So we're going to try to solve them algebraically. Well, we did something very similar to this one before. But what it says is rewrite these in terms of just sine or cosine, not in terms of 2x's and a mix of sine and cos. I just want one. So what I'm going to do with this one here is I'm going to switch the cos to be 1 minus sine squared x. That's one of the identities that you should know. And multiply that in. So 2 minus 2 sine squared x minus sine x plus 1. So I'm going to move that 1 over to the other side and make it equal to 0. Actually, I'm going to move everything to the other side of the equation, because I don't like having negatives in front of my squared pieces. Cool. Now we're going to factor this. So I know I have a 2 sine x and a sine x. I need to get a positive 1 using a 3 and a 1. The 3 is going to be positive, the 1 is going to be negative. Yeah, that looks like it should work. Okay. That's just me guessing in my mind, trying to do some mental math, but you can just factor it like a regular way. So we're going to solve for the two pieces here. I want to solve for when sine x is equal to -3/2, which there are no solutions, because that ratio is too large. And I also want to determine when the sine x is equal to 1. Remember, this is the y value, so sine x is equal to 1 in only one spot, straight up. So for one circle from 0 to 2 pi, my answer is pi over 2. That's it, just pi over 2. There's no solutions over here for that one, so my only answer is pi over 2. This is a very similar question. This time I'm going to switch the sine one to be 1 minus cos squared. 2 sine. I want to make sure that my cos is positive, so I'm going to move everything to this side of the equation. I'm going to factor this. I got a 3, I got a 1, I got a positive, I got a negative. Okay, so cos is equal to 1, and cos x is equal to -3. Again, we got no solutions on this one, right? No solutions. But this one we have, this one, remember, is your x value. So on a unit circle, x is equal to +1 in one spot, right here. Right? So my x is going to be 0. And 2 pi, but 2 pi is not, you notice that there's no equal to 2 pi here. So I only have one answer, and 0. Okay. This one here, I'm not going to try to introduce, I want to change this double angle to a single angle. So I'm not going to introduce a new thing like sine or cos. I'm going to leave that as 2 cos squared 8 minus 1. So I'm just going to change it, but I'm going to leave it as a cos rather than introducing it as a sine anywhere there. I'm just rearrange that ever so slightly because I don't like the way it's written. So my handwriting, I'm writing pretty fast here. So a 1 and a 1, that's the only way to make that. I got a 2 cos x and I got a cos x, that's the only way to make that. But I need to get a +1, so that's a positive there and a negative there. Okay. So cos x is equal to 1/2. Cos x is equal to -1. So I just have to solve these two pieces. So cos is equal to 1/2. Well, first of all, cos is equal to -1. So x is equal to pi, so 180. So remember, that's going to be over here, right? And cos is equal to 1/2, +1/2 in first quadrant and this quadrant down here. So these two quadrants, the reference angle is 60 degrees. So x is equal to pi over 3 and 5 pi over 3. There we go. Cool. See what they got for the next one. So solve this one algebraically, give a general solution. General solution this time, okay. Oh, we got a mix of cos and sine. So what I'm going to do is I'm going to switch that cos squared to a sine squared by using the identity. Multiply in the brackets. Looks very similar. Didn't we just do this one? Actually, looks very similar. I'm going to move everything to this side over here to the right side. That gives me a positive squared there. And -1. So minus the 2 over as well. Factor, 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 factor. So 2 sine x and a sine x. I know there's a 1 and a 1, but I need to get a -1 here in the middle. So that means I'm going to have to have a negative here and a positive here. Yeah. Sine x is equal to -1/2. Sine x is equal to 1. Okay. We already discussed when sine is equal to 1, didn't we? Yeah, sine is equal to 1 straight up. right here, because remember that's the y value. So at pi over 2, okay? And sine is equal to -1/2 in the bottom two quadrants, here and here. And my reference angle is 30 degrees, or pi over 6. Okay? So that is going to be, I pull my calculator here. So it's 210, but I got to change it into radians. So divide by 180. So 7 pi over 6. And this one here is going to be 11. No. Yeah, 11 pi over 6. Yeah. It's like I should memorize those, but I'm just going to do the math. Yeah, 11 pi over 6. Okay, that would be the answers within one circle with one period. Now what I'm going to do is I'm going to look at these and say, is there a pattern? Can I combine these together as one general solution? So I want to find a pattern between the numbers. So I got one going straight up. I got these two going off this direction. If I look at all the angles between these, you'll see that they're all 120 degrees, or 2 pi over 3. So there's a pattern. So I'm going to start off with pi over 2. I'm going to start off with the smallest positive angle. I'm going to add 2 pi over 3 a bunch of times to get all the other angles. And there we go. Done. Okay, so hopefully you got similar answers as I did. That was a fun one. I like that one. And I will see you in the next video. Bye.